You click this video because you are tired of sending your proprietary code to a black box API. The real stakes are that you are building hidden technical debt into your production systems, locking yourself into expensive vendors while risking data leakage. By the end of this explanation, you will understand how to shift from a cloud-first dependency to an edge-native workflow that eliminates latency costs and gives you full data sovereignty. For years, the industry has pushed a narrative that artificial intelligence must live in the cloud. The logic seemed sound at the time. Cloud providers offered massive GPU clusters that no single laptop could match. They promised that you could access the world's most powerful models with a simple API call. This cloud-first architecture became the default for every startup and enterprise. But this convenience came with a hidden price tag that many engineers are only now realizing. Every time you send a query to a remote server, you're creating a dependency on their uptime, their pricing, and their terms of service. This is where the vulnerability lies. If the API goes down, your development pipeline stops. If the vendor changes their pricing model, your budget explodes. If you accidentally send sensitive data, you have lost control of your intellectual property forever. The shift toward local AI is not just a privacy gimmick for the paranoid. It is a pragmatic engineering necessity for production-grade development. We are witnessing a maturation of open-source inference engines that has finally made running large language models on consumer hardware a viable reality. Tools like Ollama and local AI have democratized access to these powerful models. You no longer need a dedicated data center to run serious engineering tasks. The technology has evolved to the point where quantization techniques allow models like Llama 3 to run at 4-bit precision. This compression reduces the memory footprint significantly while retaining over 90% of the original performance. You can now generate complex code, debug intricate errors, and process sensitive documents entirely offline on your own machine. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. Here is the thing that changes the entire game. The cloud-first model creates a specific kind of latency that slows down your most critical workflow: iteration. When you're debugging code, you're in a state of rapid back and forth with the machine. Every API call introduces a network round trip. You wait for the request to leave your computer, travel to the cloud, get processed, and return. This delay breaks your flow state. It forces you to pause, wait, and then resume. Over a day of development, those seconds add up to hours of lost productivity. When you move to an edge-native workflow, you eliminate that network flow, you eliminate that network friction entirely. The model lives on your hard drive. The inference happens in milliseconds. You get instant feedback on your code generation requests. This speed allows you to treat the AI as an extension of your own brain rather than a slow external service. The benefits extend far beyond just speed. Consider the cost structure of cloud APIs. You pay per token. For a simple code snippet, the cost is negligible. But for a full project refactoring or a large-scale data analysis, the costs can spiral out of control. Every iteration, every failed attempt, every trial run adds to your bill. Local inference flips this economic model. You pay for the hardware once. After that, every query is free. There are no per-token fees. There are no surprise charges at the end of the month. This makes local AI the only viable path for high-volume, iterative development tasks. It transforms the cost center of AI usage into a fixed infrastructure expense that you can budget for with certainty. There is a deeper layer to this shift that relates to the nature of agentic workflows. Modern AI is not just about asking a single question and getting an answer. It is about autonomous, multi-step reasoning loops. You might ask the AI to analyze a repository, identify a vulnerability, propose a fix, and then write the unit tests to verify it. Doing this with a cloud API is fraught with risk due to rate limits and latency. The API might time out in the middle of a complex chain of thought. It might block you for exceeding your request quota. Local hardware removes these constraints. Your machine becomes a self-contained development environment capable of running long, complex agentic loops without external interference. You can let the AI work for hours on a complex task without worrying about hitting a wall. However, we must be honest about the trade-offs. The technology is not a magic bullet that replaces every cloud function. There is a concept known as cultural intelligence in AI research. Some academic studies suggest that locally hosted models may lack the nuanced, region-specific reasoning required for certain sensitive production roles without rigorous, custom fine-tuning. A base model running on your laptop might not understand the specific regulatory context of a legal firm in London or the unique coding standards of a specific tech giant without additional training. This is not a failure of the technology, but a call for better engineering practices. It means that while the base model is powerful, you must still apply your expertise to fine-tune it for your specific domain. The shift to local AI does not remove the need for engineering skill. It shifts the focus from managing API contracts to managing model quality. This brings us to the most valuable insight of this entire transition. The emergence of packaged local stacks has eliminated the operational overhead that used to make local AI seem too difficult for everyday use. You no longer need to be a system administrator to run a production-grade AI environment. You can now combine Ollama with an interface like Open Web UI, a database like Supabase, and automation tools like N8N. This creates a complete, offline-capable agent system that runs on your machine. It looks and feels like a cloud service, but it lives entirely within your perimeter. This stack allows you to deploy production-grade AI agents without maintaining complex GPU infrastructure or dealing with the fragility of cloud dependencies. You are building a system that is resilient by design because it does not rely on the internet to function. The realization that local AI is the norm for serious engineering work is not about rejecting the cloud entirely. It is about choosing the right tool for the right job. For privacy-critical tasks, latency-sensitive debugging, and high-volume code generation, the local machine is superior. It offers a level of control and efficiency that cloud APIs simply cannot match. As you move forward in your career, you should view your local machine not just as a development terminal, but as a sovereign computing environment. By adopting edge-native workflows, you are building a foundation that is secure, cost-effective, and future-proof. You are taking back control of your development process from the vendors who profit from your dependency. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.